Welcome back to the Data Science with MATLAB video series. This video will focus on pre-processing the data, which is a really important step in the data science workflow. Now that we've brought in the data, brought in a subset of the data, we want to do some pre-processing. And so there are lots and lots of ways that we want to approach this problem, or I'm actually just going to go through all of them because this is what we work with in data science. Data are just messy. They're all different types. So we're going to talk a little bit about using the best MATLAB data type for the job, how to access the data, pre-processing with different kinds of data types. And then one of the biggest headaches for me and many of us are working with missing data. And so, we'll spend some time talking about that, and then other common situations like outliers, merging data, resampling, and all those kinds of things that we'll dig into. So we're going to work with our storm event data, and then we're also going to merge this in with some current weather data just to explore a little bit and make sure that our weather data are on the right times. So let's start by examining our data. And so just to kind of remind us what we're dealing with. And sure enough, we've got numeric data, we've got our categorical data, like our state, event types. We've got times, so the beginning and end time of each storm. Then we have our damage costs, and these are currently actually strings. So, it says 2K, and so that's representing thousands. So we'll have to figure out how to deal with that. We also have the source, so, where the data were recorded from, the latitude, longitude, which we'll also need to convert to numeric. And then we have this event narrative, which is really interesting. It's a free text field that someone just described the storm. And so in our case, also access data in more complicated ways. So for example, if we want to just select data from one location, we can do that by using logic. So if we want to just see how many data points are from Alaska, we can just say data.state equals Alaska. And so we can also use this to access the data. So I can use that logical expression to represent the rows that I want to bring from the data set. Okay, so that's how I would do this for one state. Say, in this case, I just want to use data from certain sources from the US government. And so I can also select that very similarly to how we just did by representing the rows as our logical expression and then selecting all of the columns of data. And so since these are also in tables, I have some nice functions I can use to reorder and reorganize the data as I see fit, or remove the variables I don't need anymore, like the event ID in the source. And so I moved the variables, the time variables in front of the other ones. So I've been talking about tables quite a lot. Let's actually talk a bit more about how to represent data in MATLAB, generally speaking. There are sort of our traditional data types, which are numeric, char data, sort of your low-level kind of data types. And then over the past couple of years, we've introduced a lot of really nice data types for data science kind of situations. So you'll see these in the example, like categoricals, date times, durations. Our table and timetable can actually contain any of these variables. And so that's what's different about the tables that we've been using so far. You can contain a number of different data types in that table, similar to a spreadsheet. And so all of these also could be made tall. And so we'll talk about that a little bit later too, where you can treat the data which is actually out of memory just as a typical MATLAB variable. And so that kind of gives us the overview of the different data types. Let's actually now talk about some of the benefits of using these data types. So we'll start by doing our time series preprocessing. All right, so let's take another look at our table again. And so again, we have our begin times and end times. And if we wanted to do pre-processing with those times, maybe we want to change the dates, we can do all of that using date time variables. So for example, if we take a look at our beginning timestamp, this is our time of year and then time of day. And in this case, doesn't really indicate which one is the year. I probably can assume it's not the future. but we might want to just update the format to our liking. So it uses the default from the file, but we can adjust this as we like. And so now it's a little bit more readable. And now I can actually determine the duration of each storm. And so if you imagine, if we're trying to predict the damage costs or the impact of these storms, a very long tornado that lasts for 3 hours is likely more costly than a 10-minute tornado. So this is a very important variable for us in our exploration. And so now I've got the storm duration, and we can take a quick look at this. We can just use our typical stats functions like max, mean, those kinds of things to explore the time. So for example, the max duration was 743 hours, which turns out to be about a month. And the mean is about 17 hours. If we look at a histogram, this gives us a better idea of the distribution. And sure enough, these are all sort of pretty low, but then we have a couple out here that are around a month. But let's actually look at some of the it's about the top 10. So we were looking at the longest storms lasting for a whole month. Let's actually pick out the top 10 most longest storms and check these out. And so in this case, these are all droughts. And so that kind of makes a little bit more sense than a hurricane lasting for a month. All right, so if we want to do a bit more pre-processing with our time, we can create a timetable. And so it's very similar to a table, which we've been working with, but it actually uses the timestamps as the rows of the table. And so you can access the data with the time, and you can do a lot of other nice pre-processing steps that are sort of headaches sometimes when you're working with time series. Tables and timetables also contain properties that can help contain metadata. And so with these applications, you often have a lot of information about the variables that you can capture here. And so, we have our variable names, we have the time information, and then any custom properties that you want to add yourself. So our time dimension is called begin timestamp. It might be easier if I just call it time. And so let's also take a look at the range. So I want to see, make sure that the time range is correct. And so sure enough, this is from January 2016 to December 2017. Let's now take a look at our categorical data. And so categorical data, it's more, it's like a label or a repeated label. Like in this case, we have the US state or the event type. And if you use the actual categorical data type in MATLAB, you have a lot of really nice functionality that comes with it that will help you work with these kind of variables. And so first off, I can just get a quick summary. It gives me an idea of what sort of categories I have and how many. And so I can see already that I'm going to need to do some pre-processing. I probably want to remove things over bodies of water. And then for my event types, some of these could be combined. For example, maybe heavy rain and rain could be considered the same category. I also have very few of these, so we might want to remove those altogether when we're doing predictions. So we can also take a quick look at this with histogram. I've created a function to make a bigger figure, a tall figure, so that I can see all of this at once. And so, as you can see, there are lots of thunderstorm winds, high winds, lots of tornadoes, winter storms. And so you can get a quick idea of the distribution of these events. So as I mentioned, we probably want to combine some of these just to make a little bit more sense. And so maybe with wind, we could combine wind and high wind to just be all wind. And I'm going to continue this over and over again. So I've created a live function that goes through the same process for multiple other variables. So for example, snow, flood, heavy floods, those kinds of things will all be combined. And so I'll go back here, use my live function, and check out the new categories. So sure enough, this is a much more manageable list of categories, and we still have good, interesting ones like dust storms and debris flow. All right, so that takes care of our categorical data. And we also have some textual data that we need to work with. So some of it is textual by nature, like our event narratives. So, the free text that somebody actually wrote. So that's appropriate to keep as a string data type in MATLAB. The other ones in our data set are not appropriate as strings, so we're going to need to convert these. And for me, I always, if I don't know what the data type should be, or I'm not sure what it looks like, I'll just bring it in as a string so I can go ahead and pre-process and convert later, just because it's very friendly to do that. So first, I'll make sure all of the event narratives are lowercase, just so I can more easily analyze those. And then I have another function to do our string preprocessing that converts our data types. And so, for example, it's just going through and converting our latitude and longitude directly, just to double precision. And our damage cost variables, it's detecting where it says M or K for millions or thousands, and changing the units based on that. And so now I will run that function, and we'll check out our results. Now we have a much more manageable data set, and our numbers are actually numbers, and our text is text. All right, so now that everything is in the right data type, we have a lot of missing data. So we want to figure out how to approach this. And so sometimes we want to remove these, sometimes we want to fill them. We have lots of options in MATLAB. So, we could standardize, we can detect them, remove, or fill them with a bunch of different options. And so in this case, let's just take a quick look to see how much I actually have. And so if we can use isMissing, and that lets me know that, some of them have no missing data, some of them have, 13,000 missing data points. But first things first, we want to remove rows that have all missing data. And so if it's all missing except for the time, that's not helpful to us. Another thing that we need to do is add our damage costs. But sometimes there are missing data in one of those variables. And so I can tell the function to omit nans. So, just ignore the missing data as you're calculating. All right, so our event data is looking good. But now we also want to compare this to current weather data. And so we actually have, at our MathWorks headquarters in Natick, Massachusetts, we have sensors on our building that give us weather data. We use ThinkSpeak to store the data from the sensors, and I can use ThinkSpeak Read to bring that into MATLAB. Through ThinkSpeak Read, I can choose the date range. So I want to make sure I'm choosing a range from the study, and it's bringing back typical meteorological information like the wind direction, wind speed, temperature, humidity, all that kind of stuff. And we can take a quick visual look at this with a stacked plot. Whenever you pass a timetable, it'll actually show you all of the variables at once. And so as you can see, this is also a bit messy. There are some outliers. We're probably going to want to do some smoothing. So it's a little bit different types of preprocessing. So when it comes to outliers, it's very similar to our approach with missing data. So I can detect them with isOutlier, and then I can decide to remove or fill them with a bunch of different methods that the function provides. So first, let's check to see if I have outliers, and I can choose the method to detect the outliers. So in this case, I'm doing a median. And so you can see some have multiple, some have very few. I know that with the light intensity data, I want to just go ahead and fill those altogether. Another thing with sensor data is that, sometimes you might have, hourly or, data on the minute or on the second. And we want to just make sure this is consistent throughout the whole data set. It's much easier in our analysis that they're on the same time. And so we can resample or retime. And in this case, I'm going to use linear interpolation to put all of the data on the minute. And sure enough, these are all on the same time now, and I can carry on with some of my further analysis. And so, we notice there's a lot of up and down. In doing my analysis, I can just work with a smoothed set from here on out. And so the last thing I want to do is to synchronize the data. And so, I mentioned that we have all of this event data, and we only have our sensor data for, obviously Massachusetts, where the sensors are located. And so we can put these data sets together, but we want to make sure that we're being careful about the times. And so if we use Synchronize, we can actually choose what time we want. In this case, I'm saying first, so that's going to put everything on the time of the weather data. And then I can see that, February 5th, there was a winter weather warning. On the 8th, there was a blizzard. And so if I look at a plot, I can see that, these are some of the points where, the blizzard happened and there was wind that was likely related, winter weather, all kind of related and nice to see on the visual. Thanks for watching. In the next video, we'll look at analyzing our data.